So far in this course, we have seen the central role that large language models play inside an agentic AI system. Up until now, we mostly treated the LLM as a remote service, something running in the cloud provided through an API and always available over the network. But an LLM doesn't have to live in the cloud. Modern open source models can also run directly on your own machine, on your local server, or inside your organization's private infrastructure. In this video, we'll explore what that actually means. We'll look at what a local model is, how it differs from a hosted model, when local models make sense, and what their practical characteristics and limitations are. By the end, you'll have a clear mental model of when and how local LLMs fit into the agentic AI landscape. When we talk about local models, we are really talking about an entire ecosystem of open source model families that can run fully on your machine. These models vary widely in size, capability, and specialization, but they all share one thing in common. You can download the weights and run them yourself. Some of the major families you'll encounter include Llama from Meta, one of the most widely adopted open source model families, available from small, fast 3 billion and 8 billion parameter models all the way up to 70 billion plus parameter. These have strong general purpose performance and a very active fine-tuning community. Mistral and Mixtral, known for efficiency and excellent performance at smaller sizes. Mixtral variants offer very strong reasoning at lower compute cost. DeepSeek models, a newer but rapidly growing family, often offering good reasoning performance with relatively optimized architectures, commonly used for local inference because of their speed to quality ratio. Granite from IBM. Enterprise-grade open source models designed for reliability, adherence to instructions, and safety, often used in business settings and local deployments. Phi from Microsoft. Small, efficient models focus on high-quality reasoning and knowledge within constrained sizes. Great for lightweight local workloads. Alongside these, there are hundreds of community fine-tuned versions, coding optimized models, role-play assistants, reasoning enhanced models, and domain-specific variants for law, medicine, and more. In short, local models don't refer to one model. They refer to an entire landscape of open, transparent model families that can be adapted, combined, and optimized for your own environment. When working with local models, the first practical question is, where do these models actually come from? There are three main sources to be aware of. The first one is Hugging Face Model Hub. This is the central ecosystem for open source models. It hosts more than 1 million models across all categories: language, vision, multimodal embeddings, and more. If a model is open source and widely used, it is almost certainly published here first. Ollama model library. Ollama provides a curated catalog of models that are prepackaged, quantized, and optimized for local execution. Quantized means the same model weights are stored using fewer bits, making the model smaller and faster to run locally. This makes them easy to download and run with a single command without worrying about model weights, conversion steps, or GPU configuration. Next is the vendor or lab releases. Some research labs and companies publish models directly. For example, Meta for Llama, Mistral AI for Mistral, IBM for Granite, or Alibaba for Qwen. These models eventually appear in Hugging Face, but sometimes the official release happens on the provider's own website or GitHub first. Together, these sources form the discovery layer for local LLMs. They allow you to explore available models, compare versions, and pick the right one for your task. To actually use a local model, we rarely load the raw weights directly in our own code. Instead, we typically rely on a runtime that handles download, optimization, and inference for us. A common pattern looks like this. 1. Pick a model. You choose a model family and size, for example, Llama or Mistral variant, often in a quantized form, so it fits on your hardware. 2. Use a runtime to download and start it. Tools like Ollama, LM Studio, or other inference servers act as a model manager. With Ollama, for example, a single command such as Ollama run with the model name downloads the model and starts a local inference server. Next, the runtime exposes an API. Once running, the model is available on localhost as an HTTP endpoint. Much like any other web service, you can talk to it from the command line, from a script or from an agent framework by sending requests to that endpoint. From the perspective of an agentic system, this means the local model behaves very much like a remote LLM API. The difference is that the server is running on your own machine or inside your own infrastructure, and you control the model, the data, and the runtime. Local models are not a replacement for cloud LLMs, but they are an important alternative in certain situations. There are a few specific cases where running a model locally can be the better choice. For example, when privacy and data control is involved. When the data you work with is sensitive or cannot leave your machine, a local model is often the safest option. Nothing leaves the device and no external API is involved. Another reason could be costs and predictable usage. Local models run on your hardware. Once the model is downloaded, there are no per token or per request costs. If you expect frequent or sustained usage, this can make operation costs far more predictable. Another reason could be offline or edge environments. Local models are useful when internet access is limited or unavailable. For example, on laptops during travel, in field environments, or on devices deployed at the edge. Another reason could be lightweight tasks that don't require frontier performance. Not every task needs a frontier model. For summarization, code assistance, autonomous activities, or smaller reasoning tasks, many 7 billion or 8 billion local models perform well, especially when well quantized. Another reason is customization and control. Local models can be modified, extended, and fine-tuned. Developers can adjust system prompts, settings, or even the underlying weights without restrictions imposed by a hosted API. In short, local models are most useful when privacy, control, cost, or independence from cloud services matter, and when the task does not strictly require the strongest models available. While local models offer important benefits, they also come with several limitations that are important to keep in mind. First, they are constrained by your hardware. Your device determines how large or capable a model you can run. Smaller GPUs or CPUs often require heavily quantized models, which can impact reasoning, quality, and accuracy. Second, performance can be slower. Local inference, especially on consumer laptops, may introduce noticeable latency with larger prompts, complex inputs, or multimodal workloads. Third, local setups require more maintenance. You're responsible for downloading models, updating them, managing disk space, and sometimes troubleshooting driver or compatibility issues that cloud services abstract away. And finally, local models don't automatically improve over time. Unlike cloud-hosted models that are continuously updated, optimized and upgraded in the background, a local model remains exactly the version you installed until you manually replace it. So while local execution offers privacy and control, these practical constraints must be considered when deciding whether it's the right fit for your specific task or environment. In this video, we introduced the core ideas behind local models and why they matter in the context of Agentic AI. We looked at the major families of local models. We also covered where these models come from and how they are distributed. We examined how local models are run in practice, focusing on the role of a local inference server like Ollama. And finally, we discussed when local models make sense and highlighted the key trade-offs, including lower model performance and hardware limitations. Local models are becoming an increasingly important part of the landscape, giving developers more control over how AI systems are developed and integrated while designing and operating agentic AI systems.